Now we're finally going to see second differences. So second differences would be something that's quadratic. It's no longer linear in that it's just adding the same amount every time, but now we're having a second difference. Here's what I mean. Look at the difference between these two. We would say, oh, my common difference is 5, but then we'd find out saying common difference is not accurate because this difference is positive 7. And so notice these. These are not the same difference, so it's no longer common. We would just say these are the differences. And so it would seem that we have problems because they're not the same number every time. It's not common until you look at what's called the second difference. What's the difference between positive 5 and positive 7? Well, it's positive 2. And as you go across, you see this is also positive 2, this is positive 2, and this is positive 2. So this is a second difference. So this is a quadratic model. All right, so here is a showing of the values going up, and as you can see, the first term, so this is when a sub 1 is 1. All right, so we're looking at a sub 1 here. It's a value of 0. A sub 2 here is 5. 3 is 12. 4 is 21, and so on. So that's how the graph would look here. We got to find a quadratic model. So one thing we can do is we could use our calculator, and we could walk through. Sorry, I clicked the wrong one, calculator. And we could go to list and spreadsheets, and you could use this to help you out. Go to list and spreadsheets, and I'll walk you through on video because it's always good to see this one more time. And we would say the first term, second term, third term, fourth term, and I forget how many terms did they even give us? 1, 2, 3, 4, 5, 6. They gave us 6 terms. So that's a 4, and this is a 6. And now we go over here and we type in the values. The first one was 0, the second one was 5, and then we had 12, and then we had 21, and then, let's see, this increased by 9, so the next one increased by 11, so we'd have 32, next one should be 45. Let me double check one more time that I didn't make a mistake. That's the correct number. So now we know it's quadratic. So what you do is you press Menu, Statistics, and Stat Calculations. You're going to put X for the X list, Y for the Y list. It's going to copy everything over to F1. Now I'll press OK, and here's my equation. Oh, did I accidentally choose linear? I did, and so this value is not right. See how it says y equals, this is mx plus b? That's not the equation we're looking for, so I'm going to go back down here and press Menu, Statistics, Stat Calculations, and here I need to choose quadratic. Again, I put X list here, put Y list there. I want to copy this to the first because I want to copy over what it just found. So it's going to save it to F1. It's going to ask me, it's going to tell me override. Okay, so here's my equation. It's in the form ax squared plus bx plus c, the normal trinomial form. There's my a, there's my b, there's my c. Notice this equation is perfect. R squared tells you the accuracy. So this is my equation, undoubtedly so. There's no error in this whatsoever. So I'm going to copy this over. And this tells me my equation is the quadratic model would be a sub n would equal here it would be 1x squared, or in this case is going to be n squared because we're using n and not x, plus 2n minus 3. So we just substituted the n's for x's. This is my model here. That was strange. But yeah, there's my model there. So let's try, what would the 1, 2, 3, 4, 5, 6, 7th term be? Well, you would plug in 7 there. And so if we plugged in 7, first we can tell the 7th term would add 15, and so it needs to be 60. So we can tell by plugging in 7 here, or you could go again over to the calculator, and since it copied it to F1, if I press Control-Doc to get a new graph or a new document, I could add a graph. Now my information should already been copied over to F1. There it is. I press Enter, and there's my graph. And now if I went to my table, Control-T, I could see the 7th term is in fact 60. So it's working correctly. So now you have one to try, and you could use Desmos. Now if you're going to use Desmos, just as a reminder, what you'll have to do is for your equation, okay, I'm over here in Desmos. Now here's what you're going to do. You would type in the equation that you're looking for. We're looking for quadratic, so we're going to say y, but you have to name it y1. And remember, we don't put the equal sign, you do a squiggly instead, this button right there. y1 is going to represent a, and we'll say x1, ax1 plus bx, and again, we got to put a 1 here, plus c. Now, that's going to be, right now what we're looking for is, this is going to be a regression using Desmos. Now, we got to come over here and we got to add a table. And so you would here, it changed that to x2. We're going to look for x1, and we're going to also say this is y1. And so now this data will automatically get carried over to there. And so remember how our terms, we had 1, followed by 2, 3, 4, 5, and 6. And so I'm going to delete 7. We don't need to give it 7. And our values were 0, then 5, then 12, 21, 32, 45. And so this is how you do it in Desmos. And it would say our equation. And why is it not calculating that correctly? What did I do wrong here? I've discovered what I did wrong. Over here, you might have caught I did ax. So first, this should be squared after. We want to square this, so it's ax squared plus bx plus c. Now, this looks like it's hitting the points correctly, and it says our a is 1, b is 2, c is -3. Yep, it got it, and it says it's 100% accurate. So that's how you would do this using Desmos. So now, you go ahead and see if you can use that model or using Desmos and see if you can come up with an equation that models this.